All right, so it's 10 o'clock, so I'm going to get started. So welcome to another Tolo Talk, our weekly edition here. I've taken on the task of talking to you about our IMA product line, and you see it highlighted there. If you don't know me, I'm Andy Zaski, Vice President of Sales and Marketing here at Tolomatic. I'm excited to talk to you about this product. It's a product that we launched almost 10 years ago now. I was looking back this weekend at it. And it hasn't lived up to the expectations that we had when we put it out there, I'll be honest. So that's not to say we don't sell it in a lot of applications, and we have a lot of great customers. But it seems to be a harder sell. And so I wanted to take a Tolo Talk here and focus specifically on this and see if we could sort of demystify it and try and encourage you to make a stronger push in this arena. So what we're going to do today is talk quickly. I want to give you some background before we go into the applications. I want to talk about the IMA product line as it exists today. Some of the key points of differentiation, and I've got it here with me in the studio. You've got an integrated actuator and a non-integrated, and we'll talk specifically about that. So here's our RSA. This is our lead line for rod style actuators. We sell more of this than anything else. But this has all the same feature sets and capabilities up to about 7,000 pounds of force. And in a much tighter package, and allows you to sell the motor. So I just want you to be aware of that. So wherever you're thinking about selling RSA, you can also think about at least positioning with the customer the option of an IMA, and then talk to the customer about those differences. So I'll talk to you about some of the differentiation points that we like to emphasize on our IMA. And then we'll get to the meat of it here, the things that you dialed in for, the application wins as advertised. So with that, I'm going to just get going here. This gets you a nice overview of our rod style actuator line for the electric. You can see the ERD on the, I don't know if that's your left or right, but ERD started out as a very economical version. Then we added stainless steel, and now we have a hygienic line. We're going to actually launch a new line of those larger style hygienic actuators in the second quarter of 2021. We're excited about that. The RSA on the other side actually has been a staple for us for over 20 years. So this is a tried and true product. We added the HT line about 4 or 5 years ago, and we've always had the GSA, the guided version of that. The RSX is what we've been focused on over the last 3 or 4 years. We built that out with our 80, our 96, and now just recently in 2020, we launched our 128, so we can do 50,000 pounds of force. And then the IMA, we launched the IMA stainless about a year ago, and then we've had a white paint version that you can get, but we're going to focus primarily on the industrial version of that. So I'm not going to spend a lot of time on the hygienic options here around IMA. So we're just going to focus on that top box there with the standard IMA product. IMA stands for Integrated Motor and Actuator. So why is that interesting? Do we think, if you look at the competitive marketplace for the non-integrated version, the ERDs, the RSAs, there are a lot of competitors out there. So there are a lot of folks that make a non-integrated actuator. Not that they don't make it as well as Tolomatic does, of course, but they do have a product offering. So there's a fair bit of competition. But when you get over here to this integrated version, the pool gets a lot smaller. So your competition base is greatly reduced. So think about that when you're out in the marketplace. This is another good reason why you may want to lead with an integrated version, or at least put that option in front of the customer. To just highlight quickly for you what's going on, our non-integrated version on the top, the RSA24, shows the actuator with that motor mount. This is a reverse parallel configuration, called an RP, reverse parallel. You could also put it inline, and then you'd see that it would extend out. So in either configuration, inline or reverse parallel, the size required for your customer to install it is quite a bit larger for our non-integrated version. Now, it does give them some benefits. It gives them the flexibility of choosing whatever motor supplier they may want, right? There are also some features of RSA in terms of internal anti-rotate, things like that that are beneficial. There's some gear reductions you can do in the RP to help with your motor selection, maybe downsizing that. You can add a gearbox to it. So there's a number of flexible things that happen in a nice way with the non-integrated actuator. But this integrated version puts that motor and that actuator combination in a very tight package. And so we use this on robot carried devices. We use this in places of hydraulic replacement where someone's trying to fit something into an area. that otherwise really maybe wouldn't be able to accommodate something like this. So why should I sell an IMA when I could just sell the RSA? You can double your sales value. That's why. So now, instead of selling the RSA and having customers supply their own motor to it to go on there, here in this case we have an opportunity of selling the actuator and the motor in combination. Customer can still put in whatever drive solution that they're comfortable with. So if they like Siemens, if they like Rockwell, if they want to use even Mitsubishi, Nidak, etc., we've got a drive capability. We can set up this actuator to communicate and work flawlessly with those drive solutions, and it have the motor and the actuator combination tied together here. It also greatly limits the number of competitors, as we talked about, and it's a very compact solution for your customer. So what's going on inside? Seems really complicated. I know this product, I think in general, is something we don't sell as much of because it is very involved. It's pretty complicated and a little bit scary. There's a lot of unknown and uncertainty that kind of makes us feel uncomfortable. So I want to try to demystify that. Here we've got the servo motor. You can see the red and blue there. So you've got the rotor and the stator built right into the housing. So that's happening all right inside of this device here. It's heavy because of that. You got a lot of copper windings inside of here. But then retracting back inside of that is either a ball screw, or in this case, the picture that we're showing is a roller screw. So that roller screw is going to get connected to the thrust tube. It's going to extend out front here, and then it's going to retract back, and it's going to retract right back through the motor, actually. So those motor windings spin, and they're actually connected to the back end of the screw shaft, and then it drives that nut assembly with the thrust tube up and back and recessing it inside the motor, and that's what allows for us to make this very compact design. I'm not going to spend a lot of time here. You can certainly pick this up and look for it yourself, but a couple quick things. We do build this both in a ball screw orientation as well as a roller screw. So if it's going to be price competitive, go with that ball screw. If it's something that's going to really work hard and be very high cyclic application, then looking at that roller screw technology is excellent. We have great deliveries on both of these, 3 or 4 weeks. With a catalog product, 6 or 7 if you want to customize something, and we'll talk about that a little bit. A lot of different options that come along with that in terms of how you can mount this assembly. These are pre-engineered catalog options, so allows you to add a brake inside of this. We can do some anti-rotate, a number of different rod end and mounting configurations. So this is what makes this, I think, this actuator a little more challenging for you to put out in the marketplace and sell. You say, okay, I've got an actuator, I've got a motor, but now I have to connect some sort of drive to this, and I'm uncomfortable with that step. And so what we're trying to do is make this easier for you. So these are all the different servo drives and controllers that we have experience with. All of these could be mounted on a Fanuc, KUKA, ABB, or Kawasaki robot. We've got all of that worked out. Nidak drives, Siemens drives, Rockwell Automation. This is an Encompass product, and I'll talk about that a little bit. But we're working hard to make it easy for you to integrate with your OEM. Mitsubishi in particular will highlight. We're just in the final process of getting them to coordinate with us so we can use their drives. We've got 2 applications out in California actually that we're working on, very excited about with integration of a Japanese drive, which is if you may or may not recognize how challenging that can be. A lot of that's very proprietary, and they don't work well with others, or play nice, I guess I should say, with others all the time. But in this case here, we've been able to get our 2 companies together and work out the differences here. So a lot of capability, a lot of flexibility. Most of your customers are using one of these sort of drive solutions and control solutions that I'm showing on the screen today. So how do I get help on that? I'm confused. My customer is concerned. Go to our website, find our IMA page on the website, and then click down and you see we've got this Drive Integration Resource tab. You click on that, it pops up this open screen that you see on the other side. Here we have all the integration information you need, and we're starting to build this out. We just added this a month or 2 ago. So you're going to see more and more of this. Our product manager, Mike Wolfel, is working on it. We've got a lot of good information on Rockwell. We do a tremendous amount of work there, and they have 60+% of the market in North America. So here's a case where you could sell to a customer that prefers Rockwell, get the motor solution and the actuator, and then allow them to get the drive and the controls and everything else from their Rockwell provider. Here, Siemens, drive integration, we've got a lot of that worked out. NEDAC, and I'll talk about that in just a minute. We've got some interesting options for you there. And then Mitsubishi is coming soon. We're working out the final details. That should be added in the next month, maybe two, as we've got that. So, all right. The Rockwell automation we talked about here. The seamless integration with Kinetix servo drive. So something that isn't maybe as apparent, you can look here. You see all of our pictures have two connectors on the back end of it. So if you look up here, you've got these two connectors, right? One's a power connector and one's a control connector, right? The drive feedback information. Now you come here and you're seeing a single connector. So a number of the drive manufacturers are now offering a single connector option, and we have done that already. So it's already pre-engineered in our Rockwell configuration. This is something that is available and is as unique, actually, only from Tolomatic at the moment on our IMA product here with a single connector. So a point of differentiation. We've also got stroke configurable. So if they wanted 4 inches, if they wanted 9 inches, if they wanted 10.5 inches of stroke. These are differences that can help separate Tolomatic from some of the competition. XLR is going to try and sell them in fixed stroke lengths. XLR has the 2 connector right now. They're working on the 1 connector. But think about that. This is another way of differentiating and showing them that we have an Encompass partnership. These are Rockwell enabled. These will look like Rockwell motors in their drive software. So none of your customers should feel uncomfortable selling this, connecting it to a Rockwell drive, getting it up and running very quickly and easily. So, all right. NEDAC, we haven't officially announced anything here, but we've got the a partnership that we started forming with NEDAC here. They're allowing us to resell motors and drives for our actuator solution. So if you've got a non-integrated actuator here, we're going to connect a NEDAC motor to it and have a drive run that solution. And if you want to sell our IMA and you want to get the drive solution, we can work with you on that as well. They have a new software that they launched similar to what they used to have called EZ Motion. And our applications engineers here have been trained on that. We've got some documentation to help you make that simple for your customers. And that EZ Motion drive with NEDAC, this used to be Emerson, used to be Control Techniques. It's been through a couple different acquisitions. So your customers may recognize Control Techniques and feel more comfortable with that. So that's really what this is. It's a Control Techniques drive sold through NEDAC. And we can help them integrate that, and then they can send it to whatever PLC solution that they want to use for controls. So now you not only get the actuator and the motor, you can also add the drive solution to that. Just a couple key points of differentiation that I wanted to highlight with you. Our actuator looks similar to the other 2 to 4 competitors in this integrated actuator space, but there are a couple important differences that I wanted to highlight with you. So part of it's this skewed versus segmented stator winding. I'm going to talk through that in a little bit more detail. We have a low electrical time constant. I'll talk to you about that. And then I don't have a slide. I took it out just in hopes of being on time here. But we do offer our standard roller screw and we offer ball screws. We do not offer inverted roller screws. But if you do some research, our ball screw dynamic load rating is very similar to our inverted roller screw dynamic load rating. So the life expectancy you're going to get from these 2 products is going to be very similar. And we've had a lot of success converting inverted roller screw customers over to a ball screw and getting essentially equivalent life in their performance. So just a note to help you navigate going forward. Or if we need to get a little more aggressive on the standard roller screw pricing, we can explore that too, since Tolomatic's been making our own roller screws for the last 7 years or so. We've got that core capability in-house. Other things you want to make sure that you highlight with your customer, you're not going to get this product from anyone faster, right? So we can ship these in about 3 or 4 weeks. as standard. That's a lot faster than most of the competition. Competitive pricing, we have a lot of experience putting this up against the competition. We know where the market's at. And our pricing is competitive on these. Got a lot of different options here that we've talked about. And then we've got, of course, if you're in the food or a pharmaceutical application, you can move them towards this white paint type of solution, or our new all stainless steel integrated motor actuator solution that we launched about a year ago. So this looks complicated, and it is a little bit, but I'll try to simplify it. Almost every servo motor out there has a segmented stator assembly. So that's, let's see here, straight up and down, straight horizontal solution. So you've got these stacked up on top of each other. Why? Because it's the simplest, it's a little bit more compact, it's cheaper, so, and it works really well, right? So this is tried and true. However, what we've done in this design is we've created a segment or a skewed motor winding. Why have we done that? We've done that so that if you're doing a pressing application and you're, let's see here, right there, you see where right here the motor stopped, and it's right between two of these stators, right? So you're going to get a lot different power out of it than you would if it stopped just above it right on a stator assembly. So depending on where this motor stops, you can get a different force out of it. If you look over here on our skewed stator assembly, wherever you stop on this motor, you're going to get exactly the same amount of power applied from this motor. It's a little more expensive, it's a little bit longer, but it's going to give you very repeatable force. So any sort of pressing applications, any sort of applications where force and accurate force and repeatable force is important, the IMA has a huge advantage over the competition. It also results in what we call low cogging torque in terms of the amount of energy that's required to get it moving back and forward. It's not, finding those gaps between the different stator assemblies. Now, if you're going fast enough and position isn't really a big deal for you, then maybe this isn't an advantage for them. But it always helps, in my mind, to help educate a customer on a segmented stator versus skewed stator. You sound smart, right? I'm trying to sound intelligent for you here. And it's better. It absolutely is better, and won't hurt you in any other application. So at a minimum, it's better than what we've got. It also gives you this force repeatability, and we talk about torque ripple. So as you're going between those stators in this segmented version on the left-hand side here, you see where that torque ripple is more exaggerated. Now, as you skew those windings, you have a much more common and even predictable force coming out of that motor. You really reduce that torque ripple so that you're getting much more consistent force out of this motor across the entire span of the application. The last piece I want to highlight for you is this electrical time constant. This is a little bit tricky too, but the green box up in the upper left-hand corner says it best. So what this means to the customer is that we can follow the command in motion faster than the competition. So you put a competitive actuator in there and you tell it to go, it takes a little bit of time for it to hear go, process that, and then start moving. What we've done is really put in a highway, a super freeway here, so the information flows quickly and the actuator starts moving right now. So if you're trying to move dynamically, if you want quick acceleration, you're moving back and forth, we have the best electrical time constant on the market. This is the most responsive actuator out there. So why wouldn't your customer want that sort of capability? So a nice, we show you a little bit of a comparison here to versus one of our key competitors. I'll also say XLR has been a competitor of ours for a decade or more. They have shifted their focus in the marketplace a little bit, and I would encourage you to look for some of those accounts where XLR traditionally had that business. You may have opportunity to convert them. Their lead times have gotten a little longer, been some price increases. There's been a focus kind of moving away from industrial automation more into sort of defense and aerospace. And so with that, there are some customers that would potentially be open to a new solution there. I encourage you to try and explore that with them. Now we sell a lot of catalog product, and the last thing I want to do is to show you, we also do some non-catalog things. So this white paint version officially isn't in the catalog, so you got to contact us, but we do it for a number of customers. We can quickly and easily get you a price on it. We've added right in the center here a manual override. You see it in kind of a red-orange sort of piece. This is a, see here, right there. What that does is you unscrew that, take it off, you put a bit with a cordless screw, and then you can actually retract and extend the actuator without any power applied to it. So you have the ability to create movement. This has been really important. We'll talk about a security barrier application in a minute. Having the ability to move that actuator if power is lost is key, or to use it for setup and things like that. Manual override, the standard version on this IMA is an external piece that bolts to the side of it and then wraps around with a guide on it. A lot of our customers have said, hey, I bought this because I want it to be compact. I don't want something bolted to the outside of it. And so a number of folks have started being interested in this hex rod, and you see that in the lower left-hand corner. This hex rod configuration allows you to get anti-rotate inside the unit and keep the very clean and compact design of that. So think about that. We've also done some things with water cooling. If the application is going to run too hot, we put a water jacket around it. And then this one is actually going on a train application. So we've done some things to set this up for a high vibration environment with some special cables as well, and a custom paint job for fire protection. So a couple of things that we've done. And then I should mention the longer stroke lengths. These come in 18-inch stroke lengths, but we also have done 24-inch stroke lengths and are set up to do that. So that's not in the catalog today, but that is available on a custom basis. So contact us and we could put that out in a quote very quickly for you. If it's longer than 24 inches, then you got to go over to our RSA, our non-integrated version. So. And with that, we're going to get into some applications. And I picked 6. We've got 20 or more different applications, and I think you've heard a number of them in other Tolo talks. So I wanted to try and pick a few newer ones. We've got some pharmaceutical ones, some medical ones, et cetera. I focused here just on some of the more industrial sort of applications. So security barriers, and we actually have a really strong position here, and I think this is applicable in other areas as well. So think about this is an actuator that needs to move very fast. This is an application that's been done traditionally with hydraulics. It has to be a command in motion, and they also need the ability, this is where that manual override came in. If they lose power to this facility, they still need to be able to get this up or down on a security barrier. So we've seen a lot of motion there. It's also kind of in a wet environment, somewhat outside. So we've done some things on some new designs with some steels, coatings, et cetera, worked with folks on that. So there's a lot that we have to offer here. We're one of the industry leaders in these security barriers. It is a little bit smaller market, but lifting gates up and down, time is essential. It's a hydraulic replacement application. There's a lot of life cycle testing that goes on here. It's really important that this is a critical application. It's a lower duty cycle, but it's critical that when we need it to go, it moves. And in this case, as you think about hydraulic replacement, one of the driving things here was the concern with hydraulic oil leaking out of the system at some point if there's an event, and then getting into the ground. The other issue was cold and heat. So hydraulic systems, you get up into Minnesota here, freezing temperature operates a lot differently than when you're down in Florida. And so with the electric solution, now you can take away that difference in viscosity that you see in that hydraulic fluid between a freezing cold environment and a tropical 70-degree environment down in Florida, which sounds lovely at this time of year to all of us Minnesotans. So in this case, we came in, we've worked with a number of different customers successfully and displaced hydraulics. We've displaced some competition. This compact design works great because it fits in underneath this assembly. The roller screw gives them the long life. And speed is really important here. So being able to respond quickly and then drive fast up to full extension to get that gate up is really important. So we added that manual override and then a brake option as well. As soon as it's up, we apply the brake so that that stays up and you don't have to keep power to the motor then throughout the up period of the security barrier. So think about that for other applications as well. If you're going to move to a position, a standard brake option here allows you then to hold in place. It's a holding brake, and allows you then to de-energize the motor at that point. So I'll let you read through this, but we actually do, I bet, close to $1 to $2 million a year with different customers in security barrier types of applications. So really good stuff. Here's an application that's a little bit unique, and I don't know that there's a lot of helicopter simulator applications out there, but think about high frequency applications. Do you have a customer that's moving something very rapidly, okay? And we've done some work with customers that have testing. They're building testing types of equipment. We've done things with people in entertainment, with rides. We've done things with people here in simulators, both helicopter, car simulators, etc. Anything where you need quick, rapid movement and frequent movement. In this case, you can see down at the bottom, we were asked to move at 30 to 50 hertz. So about 50 times a second, this actuator is pulsing, up and down, up and down, up and down, moving very fast. The idea here is that they're going to simulate the helicopter rotor wash. So you got one or two pilots sitting up here on this hexapod. The large extended hexapods are still hydraulic solutions. And then what we're doing is we're actually vibrating the top of this assembly. And they had done it with a cogging assembly before, and it just wasn't working very well. They wasn't getting the realistic performance and feel that they wanted. They did both testing with us and our competition. We're the only one that survived the test. We designed a bit of a customized unit for their environment, and they've been a customer for years now. Really successful. They're getting very long life, longer than we expected on these actuators, which is unfortunate. I'd love to sell them a lot more replacements than I do, but the simulator business is going well, and this has been a great solution. So we took our IMA and put a preloaded roller screw inside of it, such that you're not getting any sort of movement on the nut on the screw assembly. We have a special drive for sort of a vibratory environment, and this low electrical time constant here enabled that dynamic movement back and forth. We've done some things with road testing, we've done some things with vehicle testing, body testing, etc. A number of applications here. Think about high frequency, high cyclical moves. So another win here. This is a welding win, and this design, this IMA, is the same as our servo weld. So we sell a robot carried resistant spot welding solution into the automotive marketplace. We're on spec with General Motors and Volkswagen, a few other companies. And we took that technology 10 years ago, put it into an industrial version. So all of our IMAs can be robot carried. So if your customer is going to put in a FANUC robot to do something and they need a clamping, they need a pinching, they need some sort of tooling on the end that's going to provide movement, our actuators are great for that. They're set up perfectly to do that. In this case, this customer is making this tie assembly, this construction wire that goes inside of some of the concrete that you would pour and form then for bridges, barriers, things like that. They had been doing it hydraulically. They wanted to increase some of the quality and the output of their factory. They weren't getting things always exactly the same. The hydraulic would move to wherever it moved depending on the amount of force in the hydraulic fluid, and then they weren't getting consistency. So we won this business about a year and a half ago. They're looking at doing another line. They did one of their machines. They wanted to have a simpler design so that it was easier for their operators to set up. They want to get away from the hydraulic solutions that they've been using. And so we worked with them very closely to help them specify the IMA and explain why this created a better solution for them. So we were working against a company that is actually Russian-based, this Diacon company, come out of Russia. And we were able to show that our speed and force repeatability, we talked about that skewed winding, really comes into play here. You're going to clamp and push and press at the exact same amount. So envision a servo press sort of solution here. You're doing a pressing application on the wire and then doing the weld itself. So we worked through thermal modeling on their discussion. We were able to integrate this Lenza drive that they wanted to use. And then we also offered a cooling plate that could then help them keep this cool, because this was a pretty dynamic move. They were doing this pretty frequently down their welding line. So customer loved it. They were able to get one system completely converted over. They've been running it for 6 to 12 months now, and looking at moving other lines in their facility over to this solution as well. So again, a servo pressing application. Happens to be in welding here, but certainly could be applicable to a number of other areas. Tread application. Tire industry, you wouldn't always think about that as a key growth area for us, especially in the middle of the pandemic of 2020. Not as many miles being put on tires, but some of the tire manufacturers have recognized, look, it's going to come back. Now is the time for us to do some investment. So we've done a few projects this year with tire companies, and we have more that we've been actually working on. So this is an interesting area, a very traditional business where they've used a lot of hydraulics, some pneumatics for years and years, and they're starting to try and upgrade some of their existing equipment. There's not a lot of new tire plants being built, but there are a lot of upgrade opportunities inside existing tire facilities. So again, this could be applicable to other sorts of industrial environments. So in this case, they were using pneumatic actuators to apply the tread to the tire casing, okay, but they weren't getting the exact force, right? There's a little bit of difference every time, depending on the amount of pressure that's exerted, the temperature, the frequency, the seal wear, things like that. So they also wanted to get a record of that force being applied. So you could do that potentially by adding a load cell to your pneumatic actuator, so you get a digital signature or imprint of how much force was applied. But in this case, you could use the IMA. Now you can take that motor information and you can extrapolate that back to a pressure. And now you have your digital fingerprint of every single press that you've made. You know exactly how much force was applied. So we were able to talk with them and work very closely with them to replace their pneumatic cylinder with this electric cylinder. So benefits for them, a much better product, so higher quality. They got the data collected that they needed. They wanted that signature recorded. A lot of customers want more and more of that data recorded, right? So they can look back and see if there were issues and then track any other product that might have similar issues. And then it decreased the air consumption for the plant, sort of as an added bonus. Here's an application. Everyone has been thinking a lot about paper products this in 2020. That goes from toilet paper to your Amazon box that's shipping to you, and everything in between. We are using more paper this year almost than any other year before, I think. You've got takeout boxes. I know we have pizza boxes and all sorts of things coming through our house, things being delivered every day. The paper processing industry and timber is going strong, and thank goodness, because we're all making use of that. But it's also another industry that historically has relied on hydraulics. And here they're actually doing some investment, especially in the Southeast and in the Northwest, creating new solutions of electric to replace some of their pneumatic and hydraulic solutions. So in this case, we worked with a company. They wanted to make sure that their fence positioning solution, you've got these boards coming down, they're all set down on this table and conveying line as it comes down. You can see it in the upper right hand corner, and they're all at different places, so we need to true them up, every single board. So it's pretty dynamic. These boards fly through here faster than you can imagine as they head down the line to then be trimmed up and cut to the right lengths, et cetera, or boxed and packaged. So they wanted something that was really, it needed to fit right where the hydraulic solution had fit. So you hang another servo motor on this thing, and it would be, with this non-integrated version, a little too big and stick out in the wrong places on their equipment. So they like the compact design of this IMA. So worked with them. Again, a 7.87-inch stroke, speeds that were pretty quick here, 10 inches a second, and then, pretty good thrust at 200 pounds. So now the max we can do is about 7,000, 8,000 pounds with our largest IMA. So 200 wasn't any challenge for us, but the environment is also challenging. So you think about putting these in high debris environments, wouldn't have to be timber. There's some things that we've done with the sealing and scraping assemblies here. We have some options that you can add to this. There's a special on the end of this thrust rod, there's actually a special coating here that we put on, and we did that specifically around the welding applications. Weld slag would get stuck onto the end of these things, and we didn't want that ending out back inside the actuator. So it's a salt bath nitride solution that's put on this, forms a very smooth, non-sticky coating on our thrust tube. So some special things we've done. You don't have any extra gaskets or seals with this motor solution on a non-integrated version. And then they're having some issues with seal wear on the hydraulics and stuff, just based on a lot of these timber applications are in environments where they do get cold. So temperature fluctuations were a challenge. I went up, I need to go back down. So, hey, our distributor brought this application to us. We worked with them to understand the motion profile, exactly what was happening in the environment. We were able to determine that in this case, a ball screw would work just fine. They wanted a quick move, not a lot of force. Put a 5mm ball screw in there. We were able to improve their throughput, a more consistent and repeatable design. Took their operating system and their operating costs down. Took away that hydraulic concern, and then we're able to solve this more efficiently than the hydraulic solution they had. And in this case, we put an IP67 option. So we've got IP65, we've got IP67, and then we even on our stainless offer an IP69K if you have a washdown environment. I don't know about your household, but we've been going through a lot of dishwasher fluid and pods here recently as we eat home a lot more than we maybe have before. And this company here worked with us to create a new solution for their dishwasher filling and sealing pod manufacturing. So in this case, they had a confined space. Obviously, this is a manufacturing assembly area, and they didn't have a lot of room to maneuver inside their equipment. So they were building a piece of equipment that they then sell to other places. So you got an OEM sale here. So this is once they've standardized this design, the gift that keeps giving, our repeat part number OEM type of customer we love. But they needed to fit into the solution. An integrated version fit the bill. This non-integrated version was not going to fit into their machine design, and they wanted their machine that they sell to be as small as possible. They also wanted the automation that Electric brought them and the consistency. So we contacted them. We tried a different solution. We tried an ERD, a non-integrated version. I guess the fiasco is the word here. And then they visited a competitor, and they saw some of the things that they were doing. We came back 2 years later with them, brought this integrated version, which we thought initially was going to be too expensive, right? So we lead with a less expensive option for the customer. And sometimes we do them a disservice by not showing them a few different options. So I encourage you to think about not only at least a less expensive, but maybe a most reliable, and then be able to have a conversation with them about the trade-offs and benefits of both. So in this case, we were able to kind of fight our way back into the solution. We're able to beat some of the competition based on better delivery, some flexibility in the design, and some of the integration work that we did here. In this case, we've got this white paint version that's got a stainless steel thrust tube on it and some higher ratings for washdown. And we were able to marry that with our standard industrial design. So you kind of form a hybrid here. We took the stainless steel rod and the fasteners, and then we put that back inside of this solution here, and we added our grease port on the end of the thrust tube so that you can grease the easily grease the internal roller screw or ball screw in this assembly here. So a lot of things that we did to sort of create a hybrid, semi-custom solution for the customer that then fit their needs. So very exciting, great application win. Fun to have a customer in this sort of space. So as I wrap things up, last couple slides, why is IMA a great choice for OEMs? This repeat part number OEM, I keep asking you to go quest and find more customers for us. It really creates this compact actuator motor solution that is great to fitting inside a machine. There's another customer that makes a form, fill, and seal device for the medical applications. They have about 10 of these designed into every single machine, but they wanted the machine to be as small as possible. So when you're working with OEMs, trying to build that machine, doing this allows them to reduce that footprint inside of their machine, which is a huge benefit for them and their eventual customer. I've got a lot of long life here that you can get out of the roller screw options in here. fewer components, right? You don't have a belt here. You don't have any sort of gearing. You don't have pulleys, assemblies. You don't have gaskets. So you have a much more simple solution with this IMA than a non-integrated. And some customers, that resonates with them. Very simple to install. That repeatability we talked about, this skewed winding and the benefits that bring, and this low electrical time constant for a responsiveness that you can't get from any other actuator out there. And then easy to integrate. So lots of things that you can put in front of your customer. And as I've talked with a couple of my sales guys, we love everything that our distributors are doing with us. We're seeing really strong sales growth here in the fourth quarter, and we're excited about 2021. And but we also know that we continue to struggle a little bit with this IMA and presenting it appropriately with customers. So we agreed that coming in Q1, we're going to launch a sales challenge to our distribution network, in terms of how do we sell more IMAs. And I'm open to ideas. If you have things you want to send to me, and I'd welcome that. But we're going to put together some incentives here, and we'll announce that at the first of the year to try and help encourage and reward people for presenting the IMA as an option and trying to get a little bit outside your comfort zone and think about taking a solution near the customer. That doesn't mean you have to sell the IMA alone. We can certainly represent both products. Let's give them some options, but we want you to be able to knowledgeably present both of these options to your customer and then have a discussion about that. So look for that coming soon.